Okay, guys. So, welcome to the community meeting again. As you can see, I'm in the hotel again. So, I think most of our team on the road today and the next couple of days. Um, so I think we have four agenda today. We'll get started. So I'll start with a demo and a walkthrough of the code to show you how to run a large language model with WasmEdge. I think there's at least in my opinion, the demo is pretty impressive. That's also some of the major work that we have done in the past months also, and we'd love to have your feedback as well. And then Hydai would give us a preview of the next release of WasmEdge, 0.13.5, and it can come out in about a month. Yeah, and then I'm gonna come back again and to talk about a new application that is built on top of WasmEdge, and I think it's a very, very interesting application. It's a learning assistant, and I'll show you how it works, and and you can try it yourself. I thought that's this is one of the it's one of the more interesting use cases for WasmEdge, especially in the space of AI. So yeah, so let's get started right now. And so I'm gonna share my screen. Let me see. Okay. I'm gonna share the terminal. Okay, you guys can see that, right? All right.
Yes.
Yeah. So so we're gonna go straight to the demo, and then I'm gonna tell you where to go to get those files, right? So the demo is, you can see, we run WasmEdge with some starter parameters. Essentially, we are giving it a large language model. It's called a Mistral, and I don't know if you guys heard of Mistral. It's all the rage on Twitter now. Because Facebook released llama2, and there's the 7 billion parameters, 13 billion parameters, 70 billion parameters, and the Mistral team did some fine tuning on top of it, and in most of the benchmarks, it's now beating. The Mistral 7 billion parameter model is beating llama2 13 billion parameter. So it's beating models twice its size. So and so it is a very well trained and very nice test large language model that we can use and show here, right? So we downloaded the model in the gguf format. I'm going to talk about gguf format in a minute, and then we run a WASM file. I'm going to tell you, demonstrate to you the Rust source code of that WASM file. So essentially, as you can see, it's fairly straightforward. Just to use WasmEdge to run this WASM file, passing the model as a parameter, right? So the WASM file would load the model and start trying to do inference on it. So let's see how it works. So it takes some time to start up because it is a 4 gigabytes documents, so it has to be read into the memory and be properly initiated. But now it has initiated, so it says question, right? So now we can chat with the model now. That's through the WasmEdge runtime, right? So if I say, what is the capital of Japan? Okay, so it's going to think, and now it's result. It says the capital of Japan is Tokyo, right? So the model here's this question and then generates the answer. And just to demonstrate it can actually do conversation. So I'm gonna say, what about China? It's on this question, if it's standalone, if it's a standalone question, it makes no sense. What about China? But it only makes sense in the context of this conversation, because I asked the capital of Japan first. So when I ask what's about China, I'm asking it has to follow the conversation to say, the capital of China is Beijing. It knows the context of the conversation, right? Now I can even say even more. Maybe I'm not referring to the People's Republic of China. Maybe I'm referring to the Republic of China. So it would make no sense for this question to stand alone, but it goes on to answer it. I think, in a fairly, I think, it's intelligent fashion. It's like a human, right? So it's this is just keep in mind this is the smallest model in the llama2 series. They fine-tuned it, right? So and it runs fairly fast because even this smallest model is 4 gigabytes, and we can see that the answer comes almost instantly, right? Because I'm running it completely locally, so it's just my Macintosh and running WasmEdge on top of it, right? So it makes full utilization of the GPU resources that's available on this machine. So one of the more interesting thing about WASM in this space, or WasmEdge in this in particular, it is that really raised the bar for write once, run anywhere, because this WASM file, I can copy it to a Linux machine that has NVIDIA GPU installed on it, or some other CPU machine, and it would run just without any modification, but it would run at the full capacity of the underlying machine. Meaning that's once I installed the proper version of WasmEdge, I would fully take advantage of the underlying GPU or hardware accelerator that's available on that machine without changing anything in the WASM bytecode. So if you think about the old days about Java being cross-platform, being write once, run anywhere, I'm mostly talking about CPUs, right? So it can run on different CPUs, different operating systems, and it doesn't aim to run very well on those systems, but it aims to run, right? In the world of AI and the large language model, I think the bar or the requirement for cross-platform compatibility has really been raised. We not only have to run on those different operating systems and CPUs, we have to run well, so that on those devices, it can respond really, reasonably fast, like you have just seen, right? That's it is a conversation, right? So this is one of the, I think, the chief benefits of why we use WASM, because this say if you have a Python application, you can't really take it anywhere. You have to install the whole package. You have to install pip. You have to install Python, PyTorch, and if you go any step is wrong, then it wouldn't run at all at that machine, or it would not be able to use the GPU on that machine, whatever, right? So I think the cross-platform benefit of WASM is really showing here. Is that we have a runtime that abstract away the differences in the underlying platform, so that we can make sure that this system and this application runs on all the servers, edge servers, devices, and edge devices. That's all those things that we have access to. What I also want to show you is the size of the application. So we can see those are the model files. This one is 9 gigabytes because it's the 13 gigabyte. It's the 13 billion parameters, and those two, the llama2 and the Mistral, and all those are between around 5 gigabytes. Those are not exactly small files. They are called large language model for good reason. The WASM file we have just shown that runs those files is only 2 megabytes, okay? And this 2 megabytes has all the dependencies in it. So it's self-contained binary. It's like a Java bytecode application, except it's WASM bytecode application, right? It's entirely self-contained. You can copy it, and have it run anywhere. If you if you compare this with the Python stack, in order to have a portable Python stack, you have to wrap around Python in, say, a container image, like a Docker image. And even then, you can't, say if the Docker image is built for x86, you can't really run it on ARM. If it's running on ARM, not built for NVIDIA, it wouldn't be able to take advantage of the underlying GPU, right? So it's not really cross-platform, but you can have a single, complete a package that has all the dependencies in the container format, right? So for this, I would say non-portable single binary approach in Python, you are looking at, for PyTorch, the smallest Docker image defined on the Docker Hub is 3 gigabytes, right? That's because you have all the dependencies, including all the native library dependencies, operating system dependencies, and also all the Python package dependencies. It's multi gigabytes, and here we are talking about several megabytes. So it's 3 orders of magnitude. It's 1,000 times smaller, right? That's in a distributable binary package that you can copy and move around in different devices. So that makes it, a very good choice for edge applications. So now I want to show you perhaps a more complex example, still using this 7 billion parameter Mistral model, which I can also give it a little more logging so that you can see, because I'm appending all those runtime parameters in front of WasmEdge, so that those environmental variables get passed into WasmEdge, and it controls the behavior of the application inside it, right? So if I say llama log equals 1, that means I want to turn on the logging so that I can see the information about the runtime, and the and context is the context length. It's how many parameters I can, how many characters or how many tokens I can give the runtime. That's, or give the model, right? So each model comes with certain context length, which is short-term memory. So now it's come to the point where it asks me a question. So I'm going to ask it a fairly complex question. Let me say, write a Rust function that determines if an input number is prime. So, that's a common problem, computing problem that I'm sure happens all the time in, say, GitHub Copilot and things like that. Is that you want to write a function, but you don't really want to think about how it's done. So so you ask the computer to do that, right? You ask the large language model to do that. So here's the function it gives us. Okay, function is called isPrime and takes a parameter that is an integer number. What's really, really interesting is that the main loop happens here. So the main loop is really, it's gonna starting from say number 3, and then goes up all the way to square root of n. I times I less than n. So it goes all the way up to square root of n, and then check any of those can be divided by is divisible by n. If it is, then n is not a prime number. If none of them are, then n is a prime. N is a prime number, because if n has a factor, it has to be below. One of them has to be below square root of n, right? That's something, a mathematical problem. You can work it out, right? Because if two numbers multiply together equals to n, that one of them has to be smaller than square root of n, and the other one has to be larger. So you only need to iterate all the way to square root of n. But what's really interesting, it doesn't check every single number. It goes in interval 6. Okay, so it skips all the even numbers, because there's no point of checking even numbers. And it skips over all the multiples of 3, because if n is not divisible by 3, it would not be able to divisible by all the multiples of 3 as well. So it's actually explains this logic in this little explanation. So it not only writes the code, but explains to you why it writes the code this way. This I'm actually really impressed by this, because this is I would say the quality of this code is better than a lot of the junior developers out there. We have seen people raising PRs to our project that has written code not as thoughtful, right? If you ask a junior level, someone who just come out of school, in all likelihood, he or she would not even iterate to square root of n. Would just iterate all the way to square root of to n itself, because that's the definition of prime number, right? It's a number that cannot be divided by any number that's smaller than it, right? so that's that would be inefficient. But that's you can do it with the square root of n, and then check all the numbers. That's the optimization most people can think about. But to skip all the even numbers and to skip over all the all the multiples of 3, I think that's it is a pretty high quality code, I think, right here. But you can ask follow-up questions. You can say, why not skip over multiples of 7? Now, because now it's skipping over 2, 3, but in theory, wouldn't it be better if it skips over all the multiples of all the prime numbers? Now, this is a large language model. Oh well, so maybe this is a 7 billion parameter model isn't really that smart, but it does provide a really pretty good answer to say, that's it'd be more efficient, but the function it gives is actually wrong, because it gives the same function. So that's but I believe when you get to say the because just as a reminder, ChatGPT was 175 billion parameters. This is 7 billion parameters, right? So when it goes to the level that is close to ChatGPT, it's going to get much better answers. So that's but just to keep in mind that we are running all this in WasmEdge. We are running all this with a 2 megabyte binary application. Of course, the model itself is several gigabytes, but the application itself is not several gigabytes like Python. It's 2 megabytes self-contained, all dependency included binary application. And we are running it on my local machine. It's and I can run it on a very small server, a GPU server or a CPU server, or something that has a game GPU in it, or something, or older Mac. So there's a large variety of devices that I can anywhere that WasmEdge can run. I can run this application. I can run this, AI inference application, right? So, but the thing that I really want to show is that you have seen that response fairly fast, right? So it actually achieves, 20 tokens per second. I think the previous one is 23 tokens per second. I'm running this on the laptop that is not plugged in, so it is in a reduced power and reduced performance state, and even then it would fully utilize all the hardware accelerators that's available on this device. It certainly has used the GPU. That's so I thought that's really was it's a quite impressive use of the WasmEdge runtime. And so what I want to do next is to show you how this is done. And bear with me for a second. Okay. All right. So I switch to the browser tab. And this is the entire application. You can see the entire application, including all the blank space, including all the comments and everything. It's like 64 lines of code. And the main thing is there's a loop in here. The loop is only like 30 lines of code. It's basically it takes the input and put it into what we call the prompt template, which is what's how the model is trained to follow conversations, to have those questions included in instruction tags, so that the model can generate answers, that follows those tags, right? So it basically, that's, and the important step is really just that, the one that I highlighted, that's to take the data and to take the the input that's including the prompt and the conversation history and the user question, and turn them into a tensor and then send it to the model compute and get the result back and convert them into words and sentences, and then wait for the next round of user input. That's it. That's a some people have complained, say that Rust is kind of difficult to deal with, to learn. But I think this level of code is, if you look at the large language ARM inference code that's written in Python, you'll find this is actually easier. That's if you open up a Python notebook, that's go through all this stuff that you have to take, you have to install in Python. That's this, I believe, is actually easier, and this can, again, compile down to a 2 megabytes binary that you can copy anywhere, and take advantage of the local the local hardware capabilities. And if you want to try it yourself, there's a README file. That's it's still pretty much a work in progress. And you're gonna install WasmEdge, obviously, and with the tags, with options that plug in WASI and GGML. This is a special file format for large language model that's fully taken advantage, that makes them make them smaller, because as large as 5 gigabytes a file is, it's still much smaller than the original PyTorch files that come with that's those models were originally released, right? So we have this plugin that gets to those models, and then we compile the WASM application, that the Rust application we have just seen, to the WASM application, that WASM application I've just used, right? Then you get the model, the model file, you can get it from Hugging Face, there's lots of them, just to search for the model file in GGUF formats. You find hundreds of those models, or most of them are based on llama2. That's so you can get those files, and then yeah, and then just run them like this, and you'll be able to do the same thing that I have just shown you. You can ask them a programming question. You can ask them to write some Rust code for you and then explain it, right? So yeah, that's I would really encourage you guys to try it out. I'm gonna put this in the URL of this project in the chat, so that you can try it, and then give us feedback how it works on your computer. Does it run very fast or very slow? Can you do it at all? That's run on memories, whatever. We'd love to hear your feedback, right? So yeah, that's the first segment. I just want to give you the demo of this, and we're gonna have a lot more. That's in the coming weeks, maybe by the next community meeting, that we're gonna have more models and more interesting, more knobs that we can tweak with those, and more use cases. So I really look forward to revisit this issue next month as well. But in the meanwhile, I think being part of the WasmEdge community, now you have an easy way to run those models, right? You don't need to install and multiple gigabytes of Python stuff. It's just to play with those models. You can just install WasmEdge and then have a very small file you can play with. So yeah, that's the first part of this community meeting. So the next part, I would ask Hydai to join us, and to talk about what's new with the next release of WasmEdge. Hydai.
Okay, let me share my screen first. Can you guys see my screen now?
Yes.
Oh, great. Let's get it started. And today I'm going to talk about the lens release preview, and I believe this is most related to the our new WasmEdge backend for the llama.cpp support. So you can run several LLM models with WasmEdge and this plugin. So I believe the most important feature in this release will be we add the WASI neural network, the name model options, so you can specify that the large language model, you don't need to copy the whole file into the WASM file system. The WASM memory. So you will cause something like out of memory issue in the the WASM 32 targets. So with this feature enabled, you can run not only the 7 billion, the 13 billion, maybe the the 70 billion, or like the Forecon 180 billion. It should be work because we do not we do not load the model directly into the memory. Instead, we just bypass the path, and then bypass the path to the to the llama.cpp, so it can directly load it into your something like your GPU memory. And yeah, that's a huge step. So we can support the large language model now. Yeah, and so let's talk about the the new CAPI for it. So according to the what's neural network spec and the the name model extension, we need to handle all of the external model with the following format, which is the first parameter is the model name. You can rename it in any of the name you want, and it's just alias. So you can you can use this key to look up in your Rust program. So if you check the the link, Michael just talked about that, and you can find we bypass this this alias from the argument into the into the WASI neural network function to mount it. And the second one is the model encoding. So not only you are using the GGML, for example, for the llama2 model, or you want to use some traditional machine learning models like PyTorch or TensorFlow, you just need to put your your model encoding here. And the reason is that we don't have the ability to detect what kind of this model is. For example, is a GGML or is a Python model. It's a little bit hard for us for the runtime to detect it. However, the third parameter is the hardware target, because in some special backend, I believe you have to specify the hardware target for it. But in the in the GGML case, our runtime will use the auto detect. So whenever you use the CPU, GPU, or any, or use auto, we will try to auto detect these hardware targets for you. So you don't need to worry about that. And the last part is the is the model path. So you will just pass your your model path here. Yeah. And for the second part, we are, oh sorry, I believe this first. So let's talk about how much models we already test and verified. If you want to use the use the GGML plugin that currently you must use the GGUF format. If you have the older format called the GGML format, please try to use the utilities to convert your old model into the new format before use it. Okay, then I believe we already run several models by ourselves. We can make sure they all work. And so if you are trying some pretty new framework like pretty new model like Baichuan maybe, and we have not yet tried so many models. So if you found you want to try some new model and encounter some issues, please just raise the issues on our issue board so we can continue to check it. Yeah, and also we export some some very useful options to the users. You can use the llama log. You can say to one to enable the token per second and lots of debug information from the the llama.cpp. And also you can set the number of contacts. You can set the number of predict. And this is depend on you. If you don't want to say it, the default value should be just like we show on our document or on this page. And yeah, so this thing is Michael just shared that. And we currently provide several platform support. If you are using Ubuntu, we will try to enable the Open Plus by default. So if you are use something like Ubuntu 20.04 or 22.04, please try to install the Open Plus develop first. And for the other Linux platform, we are using the main Linux platform from the pip repo. So I believe like CentOS 7 or several pretty old system can also use it. And because if you want to enable some extension on such platform, it will be harder. So in this platform, we only we didn't enable any accelerated framework for it. So it may be pretty slow than other platform because it is only rely on the CPU. Yeah, and for the Mac OS, we support Intel model and the Apple Silicon. However, because the the native support of the llama.cpp, I believe it will have some trouble on the the Intel model with the Metal framework. So we are disable it now. But if we can figure out how to make it works in the future, then we will try to enable it to do some GPU accelerator. Yeah, but for the Apple Silicon, I believe that's the most smooth CV platform you may want to try. We enable the Metal framework by default, so it will be native support with the GPU. I believe it's pretty fast. I tried to run the llama 2 chat 7 billion model on my current computer, which is the MacBook M2 Max, I guess, and I get the speed of 44 tokens per second. I believe it's pretty fast. And so if you have such platform, you can try it. You can feel like oh it's really fast. Then something just use the CPU. And for the Windows, sorry, because there are lots of stuff to do. If you use Windows, please use the WSL instead, or use Docker or anything, because currently we don't have so much engineering power to support Windows natively. Yeah, and if you want to do any platform which is not mentioned on our previous list, you can try to build from source. Then if you encounter some issue, you can just talk us and we will try to figure it out. So, and let's go back to the MSVC support. Yes, and thanks for our the LFX Benti. And currently we can compile the whole WasmEdge with the MSVC compiler. So you can check for the this workflow for the details, how to use the MSVC to compile it. And if you are interested, you can check also the document how to make this work. Yeah. So if you are on the Windows platform and you really want to use the MSVC rather than the clan for CO, and yeah, you can try it now. And the next part is our another mentee is contribute the initial support of the zzip. And this is a pretty alpha and experimental plugin, I believe. So currently we merge the initial implementation, and I believe the documents and examples are coming soon. So if you're interested in the zzip, and maybe you can share your use case or anything you want to do with it with us, and maybe we can figure out how to make this plugin communicate with the real world application. Yeah. And currently we have some limited unit test for it, so you can check this file to just go to this pull request and see the details. And this is all of our module release of the preview. And oh, sorry, I forgot to mention it. And currently I'm working on the the WasmEdge coroutines API, so we can provide another way to to make our WasmEdge more efficiency on the asynchronous or something like that, to make it faster and smoothly. Yeah, this is I'm currently working with. So I believe these 5 features will be released in our next version. And this is for the .13, right? And how about the .14? There are so many people talk to us that, hey, where is your GC proposal? Where is your exception handling? Where is your type of function reference? Yeah, we are still working on it, because there are lots of new tests that we have to verify, because that's when we want to introduce these 3 new proposals, unfortunately we have to do some breaking changes on our our C API and some definition. So it will be it will take our take more time to to do the validation for the all behavior, and we don't want to break everyone's production environment. Yeah, so it will take some time. Yeah. And somebody talk about, hey, how about the WASI Preview 2, because this spec is almost, I believe, is almost stable. Maybe some very little changes were made. However, we love, and we will, we already in progress to implement it, the WASI Preview 2. So this issue is our umbrella issue. So you can go through it and see the current the current progress of all of the Preview 2 proposals. And currently we are working on the WasIO, because all of the some of the Preview 2 proposal are rely on the other Preview 2 proposal. And let's say the WasIO is a very a very basic one. So due to the dependence graph, we are working on the WasIO first, and the WASI socket, and the WASI clock. Also, because something is very independent. So for example, the WASI run is in review, and I believe the WASI new run, as you can see our demo before, and I believe it's almost done. Yeah. So here is our our .14 release in the future, just after the our next release and the next one. Yeah. So that's all I have, and thank you.
All right, thank you, Hydai. Yeah, that's it's I think it's great. That's to talk about some of the work that goes behind all this. That's WasmEdge is part of the WASI preview too as well. So that's something we would really see that's the WASM community getting behind that, so that we would have the goal really here is to replace Python. Because Python is just a framework language over C, and WASM is a better framework language over C. Because it's because on WASM you can not only run Rust, you can run Zig, you can run Go, you can even run Python, and so I and for a lot of tasks, WASM is for 100% of tasks, WASM is much faster than Python, and also it's much smaller. It's 1,000 times smaller than Python. So that's why we we are so excited about this this whole thing. Because people were, for the longest time, people were talking about WASM was replacing Docker. Although it turns out it's very different. That's we worked with Docker. That's as to run WASM applications side by side in Kubernetes environment. I think it's now looks much more likely that's it's gonna either replace or stand side by side with Python as a C framework. That's I think that's it's really what's in my opinion, the sweet spot. Anyway, so last topic of this of today's talk, I think we only have like 10 minutes left. So I'm gonna show you something that's I find very interesting. Is if you recall the first demo I showed, I wrote a Rust application compiled to WASM, and then I asked it to write Rust application. So then it writes, the check prime application function in Rust. So it's all very interesting, because those models are really good at, programming, coming up with code, right? So one of the questions in the chat was, do you have input as to how to enable RAG implementations with this? So RAG means retrieval argument and generate, right? It's so the idea is to really to enhance and supplement the large language models programming capability by giving it more context, meaning that's to have programming related content stored in a vector database. So when the user asks a question, I search the vector database first to find the relevant content, and then tell the model to provide answers based on those content, right? So in that way, you don't need to change the model at all, not even need to fine tune it, but you need to give it external memory that's in the form of a vector database, right? So this is something that we have done exactly that. So so there's a project that we're gonna launch, I think by KubeCon this year. That's with a very large organization, what it does is that provides learning assistant for programming language topics. In this particular case, the Rust programming language, because a lot of people have questions or needs for code review and things like for Rust, right? So what we did is that we took a lot of documentation, books, tutorials around Rust and built the knowledge base, and then have a large language model behind it. Currently, we are using GPT, but we see that sometime in the near future, we would be able to replace it with large language model running by WasmEdge as well. So the interesting about this is the RAG part, the RAG part is also built by WasmEdge. So it's a Rust application that interact with the database. It's all open source, and then come up with the HTTP request that goes into the server, a WasmEdge server that hosts the large language model, and then to get the response this way. So there's lots to talk about that, but I think a lot of those content gonna we're still in the process of writing documentations, how it's done and all that, but it's all done on the flows.network. So everything is done in Rust and compiled to Wasm. There's nothing that not runs in WasmEdge. Okay, so I want to show you some of the results. So I'm gonna share my screen to Discord bot. At the end of this talk, we're gonna give you access to this Discord group so that you can ask questions, right? So this thing is called Learn Rust, and if you join this group, you can join this Discord server. You can have private messages with this Learn Rust bot, and I already have something that's here. So I ask it, can you tell me what's wrong with this code? And here's the code, right? The code looks pretty normal. I have a text. I see if the text is empty. If it is, I assign the value called hello, and then I call a function with the text, right? That's, I certainly would write code this way. When I first started with Rust, I think most a Go developer or Java developer would have no problem writing code like this, right? But it wouldn't compile. So, but the compiler doesn't really tell you how to fix it, right? So the bot tells you. The bot takes this question and search for similar problems that has happened in the past, in the examples in the docs and all that, and then provide that as a context to the large language model. So the large language model come up with this explanation. Okay, you can read this. I think it's a really good explanation of the ownership check for strings. That's so it says, it's a pointer. That's it's being scoped inside this if statement, and then when it goes out of it, it's out of scope. Tells you how to fix it. It's use own strings. You can ask furthermore more questions. What if I do not want to sorry, I'm having this thing blocking my how do I move this around? Okay. Sorry. I do not want to assign own string to text, because in my original example, text was a string slice. It's not own string, right? So it changes text to the own string. So I still want text to be the string slice. Can you come up with an example that's that? So it's that's large language model takes some time to respond, right? So it tells me, this code would work because it just use string. It's a string is a global static variable, right? So it can if you write this way, it's gonna work, right? So you can keep having those conversations, and it would explain those concepts for you. So it is a very useful learning tool. Let me have another example. Okay, so I think I copied and pasted that. Okay, so what's the problem with this code? This code is also something I think, say someone coming from Java would do this all the time. That's what's wrong with that. That's I pass in two strings, and then I try to determine which one is longer, and return the longer one. There shouldn't be any issues, isn't it? What do you guys think? Okay, so it tells you it doesn't compile because lifetime of the return reference is unclear, because there's no lifetime annotations here. So it explains that. It tells you how to use this, which I think is really interesting because and as beginners, very few people use things like this. It tells you how to make it compile and why, right? Then you can have follow-up conversations in terms of, so for instance, I can say, can X and Y have different lifetime? It is not called lifetime annotation. I'm blocking. What's that called? Maybe I just calculate. it will tell you, what's wrong with your thinking, and and why this this answer it gave is the best answer. So yeah, let's wait for the answer. See the. Okay, so there's a link in the chat. It's how do you join this Discord group? Right now this is all free. It's just come join this group and find this spot and chat with it. It tells you all kinds of, so it says you can use different lifetime annotations, but you just know what's, so it explains this. It actually does, I think, exceedingly good job to explain some of the more difficult concepts. And I've passed it around to some, Rust experts, ask them to come up with difficult examples. And, it can actually do a very good job in terms of, debugging code and then finding, especially, counter examples that has been mentioned somewhere in the past in the Rust documentation or in the Rust examples. So I thought those are very, if you're interested, I think those are very, I think it would be well worth your time. That's if you want to learn Rust, to have the code that you have problem with, or you see other people have problems, to have it come up with some kind of explanation, and it's usually right. And sometimes it gets wrong, but if it does, you can always ask it again. So yeah, that's so there's the Discord bot is probably the best way to engage with it, to ask questions. So, that's a long-winded way to answer the earlier question. Is there a way to do, to build, an REG bot around the large language model? Yes, there is. And just, the answer is flows.network, where, you use Rust to interact with the vector store, and then to build the context and the prompts for the large language model. And then you use the HTTP clients in Rust, like Tokyo and Hyper, to interact with the large language model, and then get results and then send the result back. So everything can be done in Rust, and everything runs on WasmEdge. That's So I think the story we have around large language model is coming together really nicely. We have a very compelling way to run it in a pure WASM fashion. It's all standard WASM interfaces. There's no other namespaces. There's no proprietary non-standard APIs that you have to deal with, non-native dependencies that you have to deal with. That's everything's self-contained in WASM, and you can move it around. You can run it everywhere, right? That's that's the running the inference side of the things, and then you have the whole Rust ecosystem and the infrastructure where you can build those applications around those large language models, to interact with, say, Discord, and to interact with vector stores, to interact with those external services around them, and then have those interact with have everything bridged together on the flows.network platform. Just to deploy you don't really need the flows.network platform if you don't want to use it. You can just stand up your own WasmEdge servers, because we use WasmEdge to run microservices all the time now. That's you just stand up a WasmEdge server like you would stand up any application server, right? So yeah, that's I think that'll be it, and I think that's end of the hour. And I believe Hydai has another meeting that he has to go to, but I'm gonna stay here for another 2-3 minutes to see if there's other questions that you can type in the chat, and I'll answer them. So that's but if not, there's we're gonna see you next month, when I think by then we would have made more progress on those things. Yeah.
Can I ask you just a small question? Hello.
Mm-hmm.
Yeah,
Yes.
I was the LFX mentee for the ZLib program. As we were discussing, the docs and the examples are left. Like the examples when I gave the proof of concept in April of this year, I already had a POC ready. So I will just make the PR for the example today itself, and maybe we can just push it before the 13.5 is released, so that we have the example ready before the release. And that is one thing that I will make sure that within a few hours I will just make the PR and get it merged. Okay. The second thing is like about the docs. I was thinking about the docs and presenting in this community meeting. But what I thought is like, if I just write a C program, compile it in mscript in a zlib program and run it in WasmEdge, that's okay. But the main goal of this program was to like run Python apps, because Python depends on zlib, and that is again a much more involved and complicated topic. So can I get someone with me so that I can get some help in compiling the Python library with zlib, and maybe I will have to also give a few more PRs, because libuid also needs to be needs to get its own plugin for WasmEdge. Whom should I contact for this kind of things?
Right. So I think those things we would prefer to have them discussed in GitHub, because there's multiple ways to do things like that. Like, all those native C libraries, there's at least two options. One of them is compile them to Wasm. The other one is to build plugins, so use them as host functions, right? So both ways has pros and cons. And, like FFmpeg, we have done both. We've compiled them to Wasm, but then find the performance isn't that great. So we are building a plugin now. So, that's
the thing is like since we have the zlib as a plugin, I think the performance benefits will be there a lot, and we can kind of highlight it. And I was thinking of like giving a PPT presentation about that, about giving that benchmark differences. But I got stuck because for doing that, I have to build Python first with WasmEdge plugin, and that's quite an involved process, I think. Maybe I will just make a new issue at GitHub and start the discussion there and finish the Wasm example by today. Okay.
Right. So
that will be great.
Yeah. So if you already have an issue, we can also work on that. You can just add a comment and add me, please. Yeah.
Yeah. Sure.
Yeah. I appreciate that. Thanks.
And is Asen still here? Asen Alexandrov, I think he was the one who was involved with this Python building stuff and all those things. Maybe he can guide me a lot and help me with this stuff.
Yeah, it's the Python project. We're trying to get Python connected to WasmEdge. But it takes longer than we thought.
It is quite a big API.
Yeah. All right. Okay. All right. Thank you. So yeah, that's yeah.
Before you go, I've got a question.
Yeah.
Oh, can you hear me?
Yes, I can.
Hey, my name's Stu. I'm very new here. A lot of the stuff I heard was super interesting, but also went over my head, I'm afraid. But I became aware of WasmEdge because of the QuickJS implementation that you guys have up on your GitHub organization.
Yeah.
And it seems to me, just being a newcomer, that there's so much potential in running JavaScript in a sandbox environment like Wasm through WasmEdge. Do you see people using WasmEdge with QuickJS in production in any way? And how are people deploying this stuff?
Yes. So we have users who use it in production. Actually, it's one of the big public cloud. Although they are not offering it as a public service, they're offering it as an internal service. They're offering it as a serverless function. So essentially, internal IT services allows people to deploy, JavaScript on, with some Node.js functionalities, because we implemented, a subset of the Node.js APIs. We didn't have enough manpower to implement all of them, at least until now. So they were using it as a, for lack of a better word, because if not in WasmEdge and QuickJS, they would have to run in Node.js itself. And Node.js itself would have to run in a Docker container, right? So we are talking about a massive amount of infrastructure. It's the same argument I made against Python. Is that you need to run those things in the cloud. You need a container that is huge, right? So I think that's the value they get from it. Is to to have a lightweight JavaScript environment. And currently, our Node.js implementation meets their need. But I can also see that we are not entirely compatible with Node.js because we don't implement all the APIs. So we would like to do that, but probably need some help. And we also want to add those AI inference stuff in there so that people can use JavaScript to run large language model at native speed, right? So that I think that'd be cool because all those things get delegated to the underlying hardware. So so you would run the large language model inference in JavaScript almost at the same speed as say Llama CPP. So it's I think that'd be compelling, but again, we are short of people at this moment. We'd love to see contribution. Yeah, that's all.
I think that's so cool. And I was the person, by the way, just writing the JavaScript channel in the Discord. So I was trying to get the HTTP stuff working, and experiencing a bit of slowness there. I couldn't quite figure that out. I haven't had much time to look at it, but yeah, I think that because just the Rust is cool, and then because of WasmEdge, I'm going like, oh man, maybe it's time I learn Rust. Coming from a sort of more Java TypeScripty background. Sorry, I'm taking time here, but just because of the size of the JavaScript community, and I guess because of its approachability, feels like a really I guess good direction to be going in for WasmEdge, because you open up so many more options because the community that you can unlock is so vast. Anyway, good presentation. Thanks. I'll keep quiet now.
Yeah, well, thank you. That's it's great to see you here, and we'd love to because we rely on the community to prioritize those work, right? If no one's commenting about QuickJS, then we would say, okay, maybe people do not really need those features, but if you do, then that's it helps us to prioritize those things. Yeah, definitely. Yeah.
Go.
Okay. All right. Thanks. Yeah.
Hey, Michael.
Yes.
Hey, do you have a few more minutes?
Yeah, sure. Yeah, go ahead.
Yeah. So great presentation, by the way. Really like to see the AI stuff that you guys are doing in WasmEdge. What are your thoughts around so in theory, using the WasmNN proposal, this would be portable across different Wasm runtimes, but each of them will, implement kind of their own parameters on how to load the language models or how to interact with the actual frameworks. So the binary isn't maybe necessarily quite as portable. Maybe you need to change some of the startup parameters or the way that the different WASM runtimes are integrating with the APIs for the different ML frameworks. That might be different as well. What are your thoughts around like the portability of across different WASM runtimes?
Right. So so there's so we can guarantee portability for WasmEdge running on different devices. So that's one layer of it, right? But you are talking about something else. You're talking about different runtimes. Just keep in mind, WasmNN is still in phase 2. So there are still things that gonna change. So I think WasmNN started as something that almost nobody care about, except us and the Intel. That's because it came out of Intel, and we were the first, one of the first ones we thought, that's AI inference would be a really cool use of WASM. So I think for a couple of years during the pandemic, it's only just us and them. That's and it has a very limited use case. But now I think there's much more interest in that, and also you can see the demo I gave, people who used to the large language model can immediately pick out things that are not ideal. For instance, the result come back all in once, but in most large language model applications, you see the result streaming back, right? It's like typing on the screen. So that is because WasmEdge doesn't define a streaming return function. It only defines, input is this, and then wait until the output come back, right? So I think all those things can be added to WasmEdge, and I think right now is a good time for the community to discuss this. What do we need in there, right? So I think this is yeah. So the idea really is that to make it because that's the value of the standard. If the standard is there, but still everybody have different ways to do things, I think that would defeat the purpose of the standard. So we want it to be to be fairly tied down in areas that you have just mentioned in terms of how to start a PyTorch model. I would think there shouldn't be any ambiguity in terms of different WASM runtimes. Yeah, that's yeah.
Okay, yeah, thanks. I did have one other question. This is kind of a larger sort of WasmEdge question. With Rust being such a popular language for WebAssembly, a lot of organizations are more interested in Rust these days, especially government agencies. They're really interested in a lot of the safety features that Rust provides. Was there any thoughts around WasmEdge is in C++? Is there any plans to maybe port it to Rust, or what were the original reasons to create it in C++? Maybe this is documented somewhere that you could point me to. Be happy to read that. Just curious on what your thoughts are on that.
Right. So there's two big reasons. I think the one of the biggest, WasmEdge is called WasmEdge because we see it as running in not only on the server but also in a lot of other devices. That's also why we are so interested in this portable AI story, because we wanted to be able to run it on, say, door camera and stuff like that, right? So the portability is really important to us. But in a lot of those places, I think the toolchain with has a C and C++ first. They would have those first before they have the Rust toolchain. So having C++ makes porting to those devices. For instance, we are running on, say, the Cell 4 operating system, which is a real-time operating system. It doesn't even have POSIX, but it's used in drones or autonomous vehicles, things like that, right? So those things, I think, the toolchain support for Rust would come later than C++. But on the other hand, I think it's healthy for the community to have completely different implementations of the same standard, meaning WASM standard. Say, if all the WASM runtimes are written in Rust, then not only you would have a lot of borrowing code, because say I want WASI and you already have WASI, so maybe it's Apache too, so I would just borrow it. It creates a problem in the sense that it become less stable, because if there's a critical bug in one of those, say a critical bug in Rust compiler, you would have all those runtimes have the same issue. But if, say, they are completely different, then you would not have the the problem that would say zero-day problem that are going to affect them all, right? So I think being a C++ based runtime, originally for us, it's a practical choice of a lot of devices where we want to run. But now I think it's also has value in its own diversity. That's I think it's one of the areas that diversity really brings strength. It's because you wouldn't have the, like I said, there's I remember there was in the blockchain space, there was a problem. The Ethereum blockchain used to have two clients. One is written in Go, and another one written in Rust. And the one written in Go at one time had a critical issue, and the whole system almost came down. But the ones that were in Rust was completely unaffected, so they were able to bridge over and get wait until the bugs getting fixed on the other side, right? So now I think it's a strength to be different. It's not, it's we see that we're happy that we are the different runtime out there. So
okay, great. Thank you so much. Great demo. Appreciate it.
Yeah. Thanks. Yeah.
I saw the API for the C API enablement to get the WasmEdge stuff working there. It'll be interesting to integrate that with C run. So yeah, I think that'll
exactly. So enabling that as C run and run WASI would be important for us, because that allows we have the single binary. Now the single binary can also be managed by the Kubernetes. I think that'd be a really compelling story. That's
yeah.
All right. Okay. All right. Thanks everybody. And yeah, as always, that's if you have questions, you have just reach out to me. And yeah, please.
Yeah,
just
just curious about support for writing a smart contract. If it's this is going back to the Discord, the Learn Rust model running on Discord.
Yeah. Okay. Yeah. So
no, I just no. So the question is open ended, as in what support. I mean, does the model support the development of those of that implementation of Rust to deploy them on networks, on blockchain networks?
Oh,
like helping with the code generation, including like maybe the required packages, for example, of particular name.
So the Learn Rust approach is a generic approach. We can apply it to any knowledge domain. So for instance, say a blockchain, let's say Solana or Polkadot, right? They use a lot of Rust. They have their own set of documentations, crates, and examples. We can use those as a material to build a vector database so that people can ask questions. So for instance, if now I've shown some questions here that I ask the bot, and the bot come up with pretty good answers. But say if I have a Rust source code that aimed for, say, a Solana smart contract, and it doesn't compile. If I put it in here, in all likelihood, it will not answer very well in this particular bot because it doesn't have this source material, right? And it doesn't know, that's what the correct answer looks like. So, so by using domain-specific knowledge to train it, I think it would achieve much better results, for a particular project, right? So, I don't know if that answers your question, say, because Solana has its own set of tool chains, libraries, and all that stuff, right? That's if you use that to train the bot, it would allow the bot to answer those questions much more accurately.
That makes sense. Thank you.
All right. Yep. All right then. So thank you guys. That's that's. I'm glad we have a lot of questions, and we had a good conversation. So I'll talk to you next week and next month then.